Well, hello, Thiago, and hope you're having a great Sensors Converge. I wanted to ask you about this six-axis IMU. It's got a long name. Maybe you can talk about it. What makes it different from others?
Thank you so much, Matt, and thank you for hosting me. We're talking about the LSM6 DSV32X. This device is quite unique. It offers 32G full scale on the accelerometer, 4000 DPS full scale on the gyroscope, and a series of strong embedded features into the device, such as, for example, embedded finite state machines, embedded sensor fusion, and also the ability to run machine learning models inside the device. It's called MLC.
Yeah. Well, so what do you get from that? What's it good for?
Yeah, so this device, target applications we've been working on has been primarily wearable devices, portable electronics, asset trackers, any device where you need a 6-axis IMU accelerometer and gyroscope combo, and you are power constrained. Because again, the embedded processing capabilities of this part actually allow ultra low power consumption. You can actually offload your host controller by processing sensor data inside the device.
Have you talked about the percentage gain of reduction in power?
It's quite significant. So for example, for an activity recognition library, we're talking about few microamps of processing that algorithm inside the sensor. Then at system level, the power consumption depends on the host that you're using, but it is an order of magnitude of difference.
Really?
Yes.
That's it. Good for you.
It is outstanding performance.
Yeah. So how can a developer leverage the digital functions of this device?
Yeah. So that's a great question. So the way we go to market is basically, first of all, the developer will first be able to infer sensor fusion data from the device. So that's straight up processed inside the sensor ASIC. So I can give you quaternion outputs, gravity vector, and gyroscope bias. As well as, depending on what kind of features you want to apply, we can explore finite state machines for activities that are, let's say, easier to model, where you can create your own rules from thresholds and timers. And then if you want to take a step ahead, you can actually leverage machine learning techniques to process sensor data. So in this case, for example, classify and run feature computation inside the device, as well as recognize patterns and classify multiple classes, like, for example, walking, standing up, running, riding a bike, driving. Those are all features that one could even compute inside the sensor.
So can you variably change the power consumption?
Yes. So from a device point of view, it's fully programmable. So accelerometer and gyroscope are configured independently. So they have their independent ODRs and different power modes as well. So let's say, for example, there is an embedded function on the device that we call adaptive self-configuration. So the device is actually smart enough to understand based on the conditions that we are programming, and it will change its operational modes in the runtime. So for example, I have an accelerometer in ultra low power mode. As soon as the device senses some motion, I can wake up, for example, my gyroscope and change the power mode. It's very self-sufficient in that way.
So it features in sensor fusion capabilities. I mean, we know what sensor fusion is from prior years, but what's special about that?
So first of all, the power consumption. So if we look at sensor fusion in sensor, we are talking about a 6-axis sensor fusion. So it will give you the combination of both accelerometer and gyroscope. So you have that 3D orientation of the device. As well as running, for example, at 120 hertz, you have an overhead power consumption of 30 microamps, which is outstanding. So think about, for example, 3D head tracking applications for AR glasses.
Nice example.
That can benefit a lot from embedded sensor fusion capabilities.
So any other examples?
Yeah, of course. We can also think about, for example, free fall with height estimation and then shock orientation detection. There are quite a bit of features that we can explore with this device. Then, of course, if you merge that in terms of output at system level, you for sure can even fuse with additional sensors. One of the beauty aspects of this device, and it actually can happen or operate as a sensor hub. So you can connect up to 4 external sensors and then process those external sensor data inside the IMU, leveraging some of the smart features that we talked about to process, for example, magnetometer data, pressure sensor data, temperature sensor data, and so on.
Are there target applications for it?
Yes. So let's say, for example, wearable devices heavily benefit from this. AR devices, VR devices, asset trackers. So anything that is portable, low power, where you want to sense, in this case, for example, data up to 32G, which is actually quite significant in terms of a shock event detection, for example. All that detection can happen in sensor. And plus, I think if you think about target applications for this kind of product, we're actually seeing an increase in the demand for extended full-scale solutions. So you think about any device where there is human interaction or user interface, you see that sometimes people apply different kinds of motion. And that full scale will allow for the sensor not to saturate as easily depending on the kind of motion that the user is applying.
The things that the sensor learns by the motion of the person or the device, is that something you could use to retrain in the cloud, or how would that work?
Yes. So the embedded features of the sensor, in that case, the machine learning portion itself, the device has a set of decision trees.
Yes.
So all the processing and inferencing is done inside the sensor.
Good.
However, you are creating the model outside of the device.
So some cloud.
Because, of course, we want to be very power efficient, right? Few microamps of power consumption is achieved by that architecture, very optimized. However, you have access to your raw data. So you can always feed new algorithms and keep your machine learning core solution up to date based on new data that is incoming from the field even.
Oh, you thought of everything. Nice to meet you.
I have to meet you, Matt. Thank you so much.
Yeah,
thank you.